Welcome to another episode of Discovering Disruptions in Tech. I'm your host, Howard Holton, and I'm here this week with my guest, Tyler Shields. How's it going, Tyler?
Hey, Howard. Thanks for having me on the show. Appreciate it.
Yeah, for sure. I'm really excited about this conversation, right? Because effectively, I want to dig into the disaggregation of the application. Right, we've now kind of fully broken the application down into a series of smaller parts, which are programmatically addressable, unlike the monoliths that we had before. So, what do you think? You wanna have that conversation?
Yeah. Yeah, I think it'd be fantastic. Honestly, it's there's a couple of driving factors that are causing massive changes in how cybersecurity works as a whole. And that's one of the biggest shifts that we're seeing is something I call the atomization of the application, right? And yeah, I'm happy to have that conversation. You want me to just dive right into it, or?
Well, let's set the stage, right? I think we're all aware of this kind of transition, right? We went to containers, we went to kind of microservices. We added a whole bunch of services that didn't exist before, things like service mesh, and we keep talking about how the API is the application, where before it wasn't, right? Before
Yep.
it was our data repository was the application, kind of. Now it's the API, and the API doesn't mean it lives all inside our network, all within our control, all within the boundaries of what we consider to be kind of our IT estate. APIs may be everywhere. And I will say, while we've been doing this for, I don't know, 10, 11, 12, 13 years now, we haven't really been securing it for 10, 11, 12, 13 years now. So let's kind of start there and jump in.
Yeah, it's interesting. You brought up a couple of key points, right? One is the atomization of the application story, which is kind of what you really you hit a great 30,000-foot view of it, right? It's the application used to be a monolith in our data center, then we broke it apart, and we didn't even break it apart. We jammed it into a container and called it a cloud native app, right? And then we realized that the shift to the cloud couldn't be leveraged until you decompose that application so that you could actually get cloud native scale and improvements based on the decomposition of that application into its constituent components, right? And that's where APIs, it just exploded. They absolutely exploded there, because what used to be individual functions in an application communicating with each other is now individual APIs communicating with each other, right? And that's what I call the atomization of the application, breaking it down into its atomic components. The other important part of that storyline is something I call the SaaSification of code. And so what I mean by the SaaSification of code is we used to write all our own code. You and I, we go back a long time. We probably, I'm going to speak for myself, I'm going to guess for you, wrote your own code back in the day. Wrote the majority of code that you would write, you would put together, you wrote yourself. At some point along that journey, we started using third-party libraries and bringing them into our code, right? Open source libraries. And then SaaS services came into play. And instead of now, when people write code, instead of embedding a library, they'll still do that to a degree. They'll make calls to somebody else's service in an external situation. So for example, if I wanted to send an SMS, I wouldn't write an SMS library or even embed an SMS library in my code. I would actually make a call to Twilio to send the SMS on my behalf, right? So that's what I call the SaaSification of code. So I believe that the future of libraries themselves will become more and more SaaSified. So if we couple the explosion in APIs from the atomization of code with the SaaSification of code, 100% APIs are the application now. We have micro applications everywhere that do individual features, individual functions, and that's how applications are being developed and built today. And cybersecurity has not kept up with that transition.
For sure. And let's be clear, right? It's a really good thing that we've moved to this API model. It adds a tremendous amount of consistency to how we develop. Plus, each of these APIs are, in theory, have some level of composability to them, which also means I can swap them out, I can upgrade them independently, I can replace them independently. Like, as we sit at the precipice of a Gen AI world, the only way to interface with Gen AI is through an API. And if you think the smart way to do that is to roll your own LLM, as you get started, I'm sorry I had to break it to you, everyone listening, but you're absolutely wrong. Start with something someone else has done. It's still just an API, right? So as a better model comes along, you swap it out for the better model, right? As you
Yeah,
decide, hey, I've reached the limits, I now need to train my own small, medium, or large language model. You can do that, and again, you have the composability, you have the ability to kind of change those things out and make it much, much, much more kind of purpose built, purpose focused, purpose executed than you do in that old monolith kind of model.
Yeah, when building applications, I think there's a certain amount of expertise that you have in certain algorithms or IP or uniqueness to your application that only you do, or maybe a small subset of competitors do,
Sure.
right? And then there's all the other stuff that others do 100 times better than you do. Why write a mapping system when you can make a call to Google Maps? Why write an SMS system when you can make a call to Twilio to send the SMS? Let the people that are good at what they do it and make calls to what they do, right?
Sure.
Assuming that they can provide the value that you need. And I think
It's also,
from a business perspective, it's really good that we can outsource that expertise to others.
it's not just expertise, right? But it's also management of complexity, right? Like Twilio is a great example. If I want to write an app to send an SMS and own that completely, I have just entered into the nightmare of figuring out how does AT&T versus Verizon versus Orange versus whatever other wireless company format their SMSs. What do they expect? What are the agreements they have? What are the arrangements they have? How does that work? Right? What does the billing need to look like? What do the third-party agreements need to look like? Whose license agreements do I need to now maintain? Versus I just write to send to the Twilio API and they handle it all on the back end, and I don't have to care.
Yep, you're absolutely right. So, while my day job is strategy and product marketing for Traceable, I also do a lot of investments. And one of my investment theses that I'm very excited about is actually getting behind any company that is taking a library, an open source library, and creating a service out of it. Like literally, you could go and get the top 100 most commonly used libraries inside of Java or C# or Python or whatever, make a SaaS version of it and actually update it, keep it expanding its features, etc. And you've got business models based on that because of that future of movement to SaaSification of code.
What's also we have all the supply chain attacks, right? And so there's also, if you move to a model like that, while it seems more expensive, and it likely is 99% of the time, right? When you find, hey, there's a 0-day in that library that you've integrated in 737 places within your infrastructure, and you didn't stay on top of the updates, you're going to find that 1% is so infinitely more expensive than the 99% that the economics suddenly take a shift, right? Go to a very dark place.
Yeah. And I think that's fundamentally a disruption in tech, to quote the name of your show, right? That is the disruption in technology that I think is occurring, is both of those stories that I just outlined. And cybersecurity has to reinvent itself to keep up with that. So take, for example, how cybersecurity is doing traditional AST, application security technology, right? Static analysis, dynamic analysis. Well, guess what? We don't actually own big chunks of the code anymore. Third parties are now owning big chunks of our code that we're using. We're not even having access to the libraries that we could analyze as a binary or source code blob. So how do you do AST in this new model, right? So, and a lot of it really comes down to API security, in the sense of securing API communications patterns, learning from the context of what's occurring continuously in those APIs, and then applying that context to source code analysis, or applying that context to dynamic analysis, or applying that context to runtime protection, right? And so learning, and now we can very quickly devolve into an AI question. You can quickly devolve into a big data platform question. But I think the future of cybersecurity across the board really is going to have an underpinning of API security as a fundamental component or pillar of it.
Yeah, I mean, I tend to agree, right? I think there's a few challenges. I think there's a lot of challenges, right? Not the least of which is developers don't think about security, And I don't say that it's a bad thing. I really don't.
Mhm.
Security is all about being slow, right? Development is all about being quick. I pay my developers to be fast. So if I then say, by the way, I also want you thinking about security through the whole process, I've now given them a mixed message.
Yep.
You're paid to
Yep.
be fast, but also must be slow. Makes no sense whatsoever. Right. And so a big piece of it is, how do I make sure that I've inserted that security friction at the right places and the right points in a way that is complementary to the mission of software development, as well as being complementary to the mission of protecting the business and protecting the users and protecting the data. Right. And that's where I think we need to start with. We probably need to start with a tooling conversation, right? Like, what are the tools that make sense and how do the tools work? But then build out the other pillars around it, right? Build out the rest of that tools, people, and process triangle. Go, cool. So what does our process look like to make sure we're leveraging these things properly? What do our people pieces look like to make sure we're leveraging these things properly, so that it's not just a checkbox?
Yeah, I think you're spot on. The other thing I'll throw at you there with regard to that thought process, because I love it, you're absolutely 100% right. We've said this for a long time. We can't be the department of no. We can't be the department of friction, because it lessens the business. If you lessen the business, people will work around it, right? That's been a thing we've been saying for 10 years. So no, we can't do that. But I also want to throw at you too the thought of back when we were first making transitions into the cloud, the shared responsibility model of outsourcing our infrastructure to someone else. At some point, there's also a handoff of some of the security that has to be done as well, right? Because you're
For sure.
handing that infrastructure to someone else. And yes, you have to have oversight. You have to have newer security models that lay on top of that. But look, I used to have everything in a data center. I used to have Cisco boxes racked. I used to plug in the cables myself, and I was responsible for security top to bottom across the board for that infrastructure. Well, when I take all that and put it in the cloud, am I responsible for the same levels of security across that whole stack? No, it shifts. And what we're seeing now is the transition of a shared responsibility model for application security. Where do we now start to go, look, we're actually making calls to a third-party API. Are they responsible for that section of code that drives my business? Or am I responsible for it? Do I have to now ask them for certifications that they're doing proper security on their code? Like, that shared responsibility model is still yet to be defined. And I don't think people are talking about that enough.
But well, I think the problem is, and I'm gonna break your thesis a little bit. I think you're absolutely responsible for all of it in exactly the same way. You're just not authoritative to all of it in exactly the same
Sure.
way, right?
Yep.
So I still have the responsibility to make sure that the cloud is secure, that my instance of the cloud, the things I put in the cloud, are secure end to end. But I no longer have the authority to those things kind of below layer 7, right? And so that does mean,
Or even visibility.
for
You
sure,
oftentimes don't even have visibility into it.
for sure. Right. So I don't have, I'm responsible, but I have no authority and I have no visibility. Right. So what does that look like? How does that change our thought processes? Right. What does that change
Yeah.
about, like I did networking at layer 1, 2, and 3 and 4. Right. We mess around with 4.
Mhm.
But I can't see layers 1, 2, 3, and 4 anymore. Right. I'm still responsible for the network. Plus, I used to I made all kinds of assumptions when I managed network security. As in, I really managed north-south. I didn't really manage east-west. But in the cloud, east-west is more important than north-south in most of the time,
That's a
right?
great point.
So I really have to shift how I think about these things and start thinking about them within the context of, I'm still fully responsible, but I don't have visibility and authority the way that I did before. Where do I have visibility and authority? And how does that change what my actions are? Right? Which
Yep.
I hate to say kind of steers us right back to zero trust. Right?
It's very funny you come back to that, and I'll touch on the zero trust stuff in a second, but I do want to talk about east west versus north south. Oftentimes, when I'm talking about API security to folks, they'll come back with me and go, "Hey, I've got Akamai on the edge, or I've got Cloudflare on the edge, or I've got a CDN or a WAF in place." Right? I got API security. I'm filtering the inbound. I'm sanitizing the outbound requests. I've got this under control. But really quickly, when you start to explain to them how the application has become atomized, and it's not just one request in anymore, it's one request that may cross that boundary, and then 10,000 internal requests, or thousands of APIs communicating with each other, calling third parties out other avenues. they quickly go, oh, wow, you're right. East-west is so much more important in making smart security decisions than north-south. And if we really want to talk about Gen AI, the discovery of the use of Gen AI within your organization, and I'm not talking about, Tyler at his desk going to Chat GPT. I'm
For
talking
sure.
about the use of your applications making calls to Gen AI. Developers can make those system calls immediately today, and you may not even know it as a security team, right? This stuff's happening in the shadows, behind the scenes, rogue API calls. If you have the ability to discover the existence of all of your API calls by looking at the traffic on the network as it traverses the network edge, as it goes east-west across the board, not just north-south, you can start to say, oh, wait, I'm making that app or API is making a call out to ChatGPT or Gemini. Oh, wait, that one is making a call to an internal open source Llama deployment. Okay, that's another Gen AI call. And you can enumerate and discover the use of Gen AI within your applications by having a strong API security program in place as well.
Yeah. Let's also API security is in some ways more complex than almost any other type of security. And the reason for it is we must be able to do two things. I have to look for malformed requests easier. I was going to say easy, but of the two,
Easier.
it is the easy one, but it is just easier. It's still not easy. The second one I have to do is look for malintentioned requests. So let's break those down, right? So we start with malformed. Malformed is something that generally looks like a SQL injection attack. Like, we're very used to those. We know what they look like. They immediately go, yeah, that's not what this should look like, and we can drop those. We use effectively everything we've learned about cybersecurity for the last 40 years and apply that to API requests. Because again, we know what a properly formed API request will look like, and thus we can identify those that are malformed. So those are malformed. Those are if you have a tool, let's forget about Traceable just for a second. If you have a tool, those ones you're going to get the most protection against. Probably not perfect. I don't think there's any security tool that we could say it's perfect. And there'll be different grades of the kind of the level of efficacy of all the API tools in dealing with those. But again, the efficacy there is going to be much higher. Let's talk about the other side, right? Because one of the things that APIs are so good at is sharing data. That's their entire purpose, which also means one of the things they're so bad at is stopping you from oversharing data, right? APIs don't have anything built into them that stops the default value of oversharing data. So this is where we get into malintentioned. Malintentioned is select star from customers, right? This is the ability for someone to make a call to your API that returns far more data than they should have access to.
So there's a couple things I'll throw at you here. I want to touch on the opening part of what you talked about the ability to detect malformed. You're 100% right, and specifically one of the reasons why is APIs are much more deterministic because they have a set specification of post to this endpoint needs these 4 parameters that are all of these integer or variable types, int, whatever, right? And so you can tell, even if it's like, hey, this int has to be between 0 and 256. If it's 257, it's malformed, right? So it's much more deterministic versus a traditional web app. So that's the primary reason why a lot of that stuff can be a little bit more accurate and easier, 100%. Right? Which I agree with. As soon as you step beyond that and you start to understand any one API request there's 2 things. Any one API request is not an application as a whole. As soon as you start to realize that one API request actually feathers out to 20, 30, 50, internal, external, et cetera, you start to realize you can't just look at one individual API request and go, we're going to secure that. What you have to look at is the holistic nature of the API requests and how they all communicate and do session tracing and user tracing between all of them and make connections from a telemetry standpoint on all of that context. That's the only way you can make smart decisions on what shouldn't be shared. Try to understand intent, what's good, what's bad. All of those things start to tease out when you have that broad corpus of data. So that's one of the reasons, again, why east-west and external third-party calls become so much more important than just north-south. So that's another piece. And then you can go even further. assuming you can even solve that problem. Then you go even further and you start to talk about fraud, which all of the requests are totally normal, but it's a request pattern of log in, create new account, change password, do a financial request to make sure it works, then do 100,000 financial requests quickly. Like all of those individually are 100% perfectly valid transactions.
Correct.
But taken as a whole, it's clearly fraud, right?
Yep.
And so then you basically have to look at the holistic nature and understand the sessions and how it all traces together and stitches together into a pattern.
Yeah. There's some really interesting stories that occur there, right? Where client side and server side aren't the same thing either, right? And so there's a bank that embedded all of their validation in the client side of the API, not in the server side of the API.
Yep.
Right, which allowed
that ain't gonna work.
It works great if you're not the bank.
Yeah.
Right.
Yes.
Right. If you're an attacker, it works great because the attacker just drops all of the validation pieces.
Yep.
And little things like the service fee was on the client side. Oh, cool. I don't want a service fee. I dropped the service fee. The timeout was on the client side. Cool. Just drop that. Right. All of a sudden, it went from, hey, here's a service that you could use to do currency exchange, and you do currency exchange 1, 2, 3 times a day. Fine, no big deal. To, ooh, look, because of the rounding algorithm, and I could set that from the client side, right? What happens to the discarded pennies? The fact that there's no checks whatsoever, and the bank only checks, the financial requirements are you only have to do a check if you don't have the currency on hand. I can do bi-directional currency trades an infinite number of times in a day, and effectively, as long as it never exceeds the amount of currency you have on hand, which is easy. If I trade $1 for $1 and then $1 back to $1, you maintain most of that money on hand. And at the end of the day, I can walk away with $10, $100, $1,000, $1 million because I'm controlling little things like the rounding. Currency exchanges are not perfect, right? So I'm controlling things like the rounding, and there's no fee. So there's absolutely no cost to me. Why? Because you put it all on the client side. You're doing no server-side checking, right? Because, again, it's expedient. It's easy. I can write to the API, rock and roll, right? Away we go. And then we get into neat and interesting things like if I use a third-party API, which I use 1 million of them, even if that API is a library that I deploy inside my environment, as an example, right, versus a library as a service, which I'm totally copywriting Laz when we get off this phone call.
I love it. Go for it.
Library as a service. Just because I need 3 functions, the API may actually return 99.
Sure.
Even though I only ever use 3, there's a whole manual of things available. So what am I doing to make sure that I only ever return those 3, even though the API is capable of returning 99? Right? Again, totally valid, misintentioned, not malformed, malintentioned, not malformed uses of an API.
Yep.
Right. So what do I do to protect against those type of things?
Yeah. What the biggest issue that I think a lot of people haven't figured out yet is storing data long term, or at least semi long term. So instead of you can kind of think of this as like the old traditional WAFs, right? When they were looking at inbound and outbound requests, they could find a SQL injection because they had a tick or 1 = 1 in it, and boom, that's a clear SQL injection, right? But what they really struggled with was long tail processes of behavioral style attacks that were all legit, but right. So how do we solve that problem? We solve that problem by keeping a long tail of data of every request, not just the edge, but all the comms patterns between every function of your app, which equates to API calls, keeping all that information. And then honestly, today, the right way to start to analyze it is to overlay AI analysis over the top of that and look at it as a holistic data set and say, hey, where are we seeing clusters of patterns of usage that aren't common? So we have a baseline normative approach. We know what normal looks like. 2 weeks from now, 2 months from now, 2 years from now, whatever it is, all of a sudden you see this cluster of activity that's happening over here in your graph. And you're like, wait a minute, why is there 10,000 new accounts being set up every single day? Well, what are those doing, right? So you have to look at it, and this is the switch from signature-based to behavioral-based, and from behavioral-based to AI-backed analysis, holistic analysis. All of that comes from holding onto that data for a longer period of time so you have a corpus that you can analyze.
You need dimensions for security to work.
Correct.
Right? I don't need data points. I need dimensions. And dimensionality is a really hard, really complex thing to do. Well, while you were talking, the perfect analogy is fingerprinting, and yet I feel like we've fallen out of the habit of using fingerprinting as an analogy within like what we do, right? And I'm just kind of as a side, an aside, I just wonder when that happened. Like I felt like 10 years ago I heard fingerprinting a lot, and today it seems like everybody purposely goes out of the way to avoid using that term.
Yeah, it's a good question. I don't think I ever noticed that it fell out of favor, but 100% did. I haven't heard the term
Right?
fingerprinting in a long time. But it's
And yet,
essentially the same thing. If you think about what makes up an ML model or an AI model, and I am not an AI guru, so I'm sure the AI wonks and experts that are listening to your show right now are going to roll their eyes at some of the stuff I'm about to say. So take it with a grain of salt. But it's understanding a number of feature vectors, aka components of your fingerprint, that make up a fingerprint. It's understanding the feature vectors that make up an activity, right? And that's really what holistically AI is doing, is looking at all the feature vectors and saying that is a fingerprint, that is an activity. And what we want to do is look for activities that are different, are anomalous, alert someone to look at those that are coming into play as a broad activity and say, is this okay? Right? Because the hardest thing for AI to truly understand is intent of action. It can determine that an action is new, unique, or different easily, but is it good or bad?
right.
And really, a good example I used to use, because I used to run an ML style technology in mobile, was if I have a tic-tac-toe game on a mobile app that's a tic-tac-toe game that you're playing, and it grabs all your contacts and sends them to China, is that malicious? Well, we all know that it is. What happens if it's a contact database that gives you the option to send your contacts off to wherever you want and you happen to send them to China? Is that malicious? No, it's not. I chose to send them to my friend in China. So intent, the activities are the same, the code's the same, the fingerprint's the same, but it's difficult to understand intent. And that's where I think the next generation of generative AI that we're going to be layering on a lot of these technologies in cyber in general will help us solve a problem, helping to truly understand where intent is successful or not. And this is where I get out of my depth in AI, just like that.
Sure. I mean, no matter what we do, AI is still just a mathematical model. It's just a mathematical model with a tremendous amount of dimensionality to it, right?
Of data behind it. That's
And correct, right? And it gets that from the data. You don't have a choice, because no matter what you do, AI has to see data to learn what to do and how to make the decisions, and then to validate that it's making the right decisions, right?
That's right.
But it does remind me. I one of the things I did early on in my career was fingerprint analysis. My company developed a fingerprint, a biometric lock at its most basic format. The thing that we did that was different was everybody else was effectively building goofy pictures like you would see on CSI, right? Swirls and whirls. And it was, triangles and squares that created a geometric shape that would be overlaid. We created an encoding. And the beauty was we created an encoding that allowed you to do a percentage comparison. And at the time, that's not what we were doing. We were just overlaying pictures. And that percentage comparison meant a few things could happen. One, you could rotate your finger in 360 degrees. It didn't change the encoding. And I could set a low priority lock, a medium priority lock, a high priority lock, and a confidential lock, all of which had different requirements. So I want someone to get into the building really fast, because the likelihood that someone's fingerprint's going to match at 90% is 1 in 750,000. Okay, cool. Let them go through. And the processing time is 1/10 of a second. Versus if I set that to 100%, the processing time is 12 seconds. But it's worth 12 seconds on a laboratory door that has sensitive material behind on the other side of the door, right? And that's kind of what we need to be able to do with AI as well. How important is this activity? To what level do we need to ratchet this down? What does the percentage of match need to be? Right.
I love that thread, Howard. I love that thread, because in Gen AI, in a general sense, one of the things that people are always talking about now is shrinking the form factor to be usable on my mobile phone. And, really what needs to happen there is it has to happen in milliseconds as opposed to 10 to 15 seconds. And it's kind of what you're getting at, right? You're going to decrease accuracy and trade off for time. There's always trade-offs in everything in computer science. If we take that to the cyber world, which is what we're here to discuss, that trade-off becomes very important, because you're saying, hey, we're going to be a little looser because we want the speed, or, hey, we don't care about that speed so much as making sure we never let a bad activity happen, right? And so there will be trade-offs that we will have to have from a cybersecurity AI perspective. And I think you're going to see a lot of the big players, the Palos, the CrowdStrikes, the folks that are making these massive AI-based platforms that are collecting huge quantities of data and are going to store that data over time. Those trade-offs are going to become very important for those companies to understand as they continue to roll out cyber protections on top of AI.
Yeah, they're going to become wickedly important. And it's going to be really easy for us to make mistakes on both sides, right? It's going to be easy for the vendors to make mistakes. It's going to be easy for us as customers to make mistakes. One of the things that would be really useful is data classification within the security model. Right. So I have much less concern about data leakage when the data leakage is measured in bits or small numbers of bytes and contains no PII, versus if neither of those things are true, right? If it's a large amount of data and or it contains PII, I want to ratchet the sensitivity up, right? And so
look at the acquisitions. Look at the acquisitions that Palo and others have made recently. Dig, I think Flow might have been another one. They're buying those to do exactly what you're talking about, to make sure that the data classification is appropriately ratcheted up.
Yeah. I mean, it's interesting having watched kind of what's occurring, and cybersecurity companies are just data companies with a different focus, right? I'm not focused on the presentation of data. I'm focused on the preservation of control.
Yeah.
Right. But I still have to do all the same things. I still have to have the same ability to transact. I have to have the same ability to inspect. I have to have the same ability to react. I'm just doing it in a way where the outcome isn't let's make better business decisions, but let's make better security decisions or compliance decisions or governance decisions, right? It's a really,
I love that analogy.
Direction
that's
that's
spot on. Yeah, it's a spot on analogy. I think you're making total sense. I think it's, both fundamentally at the API security level, which I play day to day at, and if we're talking about the AI derived broader cybersecurity landscape at these platform levels in publicly traded companies, 100% these are the trade-offs that are going to have to be analyzed.
Yep. And you can't do behavior analytics anymore without a good AI and ML team.
Totally true.
Right. I mean, from the
that's why those guys are making $500,000 a year.
Right. But I think it's also a good question for customers to ask, right? Like when you're in the buying cycle and someone says we do behavior analytics, say, great. How big is your data science team? What does that team look like? Who are the people? And can I talk to one of them?
Yeah, I will say yes. And then I will also double click on that and say, okay, let's just assume your ML algorithms are cutting edge and your AI is cutting edge based on the fact that you have 20 PhDs from Stanford and MIT or whatever. The other thing is, what's your corpus of data that you're able to collect and broadly analyze, and how long do you keep it for? Because if you're only keeping it for 24 hours, you're never going to give me a holistic view. If you're keeping it for 90 days, at least I'll have a certain amount of data analysis that can be done over time. So I think doubling down on the data collected as well as the algorithms overlaid on top of it, and understanding where both of those are strong, is a great differentiator to understand who's going to do well from a product perspective.
For sure. I will also caution, I'm not asking you to have a deep understanding of those things. I'm asking you to ask questions and see, do the responses sound clear, coherent, and confident, or are the responses vague? Right? Are they kind of wishy-washy? And at the end of it, do they actually say nothing? Right? Are they very, very hand wavy?
Yeah.
Right.
Yeah.
So that's really, a thing that I would encourage. And for those that are security vendors right now that don't have that capability, like throw your shingle up, make sure you have a for sale sign posted. Somebody's going to buy you that can do those things. I don't have another response. I'm sorry. I just don't see a future where security companies aren't also data and analytics and AI companies, right?
100%. And as I mentioned earlier, as an investor in cyber companies, I haven't invested in 12 months because I'm worried about so many companies, of these little companies, that don't have a path to understanding that exact solution right now, that I've actually slowed my investing down considerably.
Right. No, that makes total sense. So as we start to kind of get to the end here, we're probably coming up on 35-ish minutes. What are the 3, 4, 5 takeaways that you'd give someone to say, hey, like this is a problem. Here's 3, 4, 5 things that maybe you should do or read or look into or take as next steps within your organization?
Yeah, so I'm going to scope that to an API security version of that question as opposed
Sure.
to a global
No,
AI
no.
security version.
Specifically API security. Yeah.
Yeah. So step one is knowing what you have. Majority of enterprises that I talk to, they come to me and they go, we don't even know what APIs we have. Or they'll say, hey, we've got 50 APIs managed under MuleSoft or Kong or whatever API gateway. They don't have a true understanding of where every API call is occurring within their environment. So step one is get a tool in there that's going to find, discover, catalog, and make sure that you know what APIs exist in your environment. Before you even worry about protecting them, just try to figure out what you got. Once you're in a position where you have a reasonable percentage or think you have a reasonable percentage of coverage, then start to build your program around protection, detection, and actually blocking things in real time. And then last but not least, I would say don't leave aside forensics and data collection over time, because just because you can see it and protect against it, you can't just delete that data and say we're good to go, because inevitably when something does happen, you're going to want to have that information to go back and analyze. So don't forget the forensic sides, the root cause analysis, the data digging that you're going to want to do later. And then the last thing I'll say is, as you start to understand what that entire ecosystem of API security looks like, use that data to make everything else better. So for example, take that data and then say, great, how can we do API security testing better? Well, look, we have 6 months worth of API requests for every API in our environment. Let's make our API testing algorithms smarter based on that context that we have at runtime. So take your runtime data and apply it to all of your other systems to level those up over time. The best vendors will have that baked in. Some of them won't. And oftentimes you'll also be able to use that data set that you have in your own processes and other things that you're doing to make them more accurate over time. So don't leave that data, leverage that data set as much as possible.
Excellent. If I could add one, the one I would add is use this as a time to create bridges between security and the data team, to create bridges between security and the software development team, because you're likely to uncover insights about how you're using APIs that make you go, why are we doing that?
Yep.
Right. And bring those things back. Every additional bit you transfer is money you're costing your company. Right. So also leverage it from that standpoint to say, hey, we could sanitize, we could clean up, we could have better practices from the development side or from the data side if we took the following actions.
Yep. I love it.
Well, Tyler, this has been fantastic. I learned quite a lot, as I like to do in this podcast. It's part of the reason I run the podcast. So this has been a lot of fun. This has been another episode of Discovering Disruptions in Tech. Please like, subscribe, follow, share, comment, do all the things. And if you'd like to reach Tyler, what's the best way for people to contact you?
I am at tyler.shields@traceable.ai.
Fantastic. So I hope everybody had a great time. Again, Tyler, I had a great time. I hope you did too. And we'll see you all on the next episode. Thanks, everybody.